हेलो।
कैसे लेकिन मुझे पता
Can you hear me?
Good evening, sir.
Yeah, good evening. Have you looked at the definite integrals part?
Yes, sir.
Before that, did you have any problems in any of the integrals, any other things in integration?
No, sir. I wasn't able to solve much. I only solved three integrals.
Okay. Uh, you need to practice more. You can't not solve it. You have to do it because otherwise you'll not be able to do physics properly. Okay. Did you read the
Yes, sir.
NCERT textbook for definite integrals?
Yes, sir. I did that.
What have you understood so far?
So I understood why the constant is added and how integration is related to differentiation and the rules for integration.
That was the previous class, no? That was indefinite integral, no? That we have already discussed.
Oh, definitely.
Did you?
Sorry, sir. Indefinite. Yes, I also read definite.
What do you understand by this? Integral a to b fx dx. What is the meaning of that?
We integrate fx and then put a in fx and then subtract it with b in fx.
No, you are saying it opposite. You first have to put b, g of b plus c, and then subtract g of a plus c, right?
Yeah.
So you will get g
Yes,
of
sir.
b minus g of a. That will be your answer for integral of a to b fx dx, right?
Yes, sir.
But that is just a way to calculate it. What is the meaning of this? What does this mean?
It's the area under a curve from a to b on the x-axis.
Okay, so f of x is like this. Then you have x is equal to a here and x is equal to b here. Then between a and b, area under the curve towards the x-axis. That means integral a to b f of x dx, right?
Yes, sir. Yes, sir.
So this will be very useful for us because many times you will have to do in physics, you will have to do area under a velocity time graph, area under a acceleration time graph. Many times you will have to do these things. So,
Yeah.
so that will give us, for example, if velocity is the derivative of the displacement, you can now say v dt is equal to ds and then integrate it from some initial time 0 to final time t, and it will give us the total displacement because this will be the area under the velocity time graph, right? From time 0 to time t,
Yes, sir.
area under a velocity time graph should give us the displacement that is covered in that time.
Yeah.
So definite integral is a way to find area under the curve. That is what you need to know. And how do we find the definite integral? We can find it by, first of all, ignoring the definite integral part. You just calculate the integral. You'll get gx plus c, right? And then you have to put the limits of integration a to b. So you will
Yes.
put g of b plus c minus g of a plus c, and then you will get basically g of b minus g of a, right?
Yes, sir.
So let's calculate. Have you done any questions in this definite integral thing?
Yes,
No.
sir.
Do you have any problems? What is 0 to pi sin x dx?
Minus 1
No.
Minus cos x. 1,
This
1. Sorry, sir.
no, calculate it correctly. You are still making a mistake.
Wait, sir. So it should be. Oh,
You don't know the value of cos pi.
so I misread as. I misread it as pi by 2.
It's not pi by 2, no, it is 0 to pi.
Yes, sir. I miscomprehended it. I
If
thought
you
pi was 90.
if you look at the graph of the sine function, 0 to pi, it is always positive, and then pi to 2 pi, it is negative. So this is the area under the curve that we are trying to find,
Yes,
right?
sir.
If you calculate the same thing
Yeah.
from 0 to 2 pi, for example, sin x dx, you will realize that it will come out to be 0 now, minus cos x plus c. If you evaluate from 0 to 2 pi, so you'll get a minus cos 2 pi plus c minus cos 0 plus c, right? So it will be cos 0
Yeah.
minus cos 2 pi, which is basically 1 minus 1, right? Do you understand how it is
Yes,
coming
sir.
as 0, this thing? So why is
Yes,
it
sir.
coming as 0? Because in this portion, the area will be
The
minus
line is
1.
flat from.
This portion,
Yeah.
not minus 1, minus 2, because this portion, the area was plus 2, right? So overall area adds up from 0 to
Yeah.
pi to
Yeah.
pi to 2 pi, it adds up. But when you do definite integral, the area is added with the sign, plus 2 minus 2, it becomes 0, right? Normally in lower
Yes, sir.
classes, when you have seen area, we don't assign a sign to the area. But here, when we are doing the area, the area below the x-axis is given a negative sign. Okay.
Yes, sir.
So actual total area is 4, but the overall area gets cancelled because we call this as minus 2 and this as plus 2, right?
Yes, sir.
Now, there are a couple of important properties of definite integrals that you need to know. So for example, if you have a to b f of x dx, right? This will be the same as a to b f of a plus b minus x dx. This is one of the most important properties. Okay.
Yeah.
So how do we know this? How do we prove this? So what we will do is we'll work with the right hand side here, right hand side, which is a to b f of a plus b minus x dx. And one thing before we discuss this property, one thing that you need to know is if you have a to b f of x dx, that is the same as a to b f of t dt. Because the change of variable doesn't matter as long as this is just a dummy variable, x and t, right? It doesn't
Yeah.
matter because the function will still look the same, right?
Yes, sir.
The area under f of t dt, f of t with the t axis will be same as the area under f of x in the x axis, right?
Yes, sir.
As long as the limits are the same, the nature of the variable doesn't matter. If the function is the same, the area will be the same, right?
Yeah.
Okay. So now we want to prove this property. So let's see how we prove that. And we'll take advantage of the method that we have learned, which is substitution method. Okay.
Okay.
So substitution method we know we can change the variable. So we can say a plus b minus x. Let's call it as t for now, right?
Okay.
A and b are constants. So if we differentiate, dt by dx would be -1, right?
Yeah.
So that means dt would be equal to minus dx.
Yes, sir.
So this integral starts looking like f of t, and instead of dx, I can put a minus dt, right?
Yeah.
And now look at the limits here. Now this function is a function on t, right?
Yeah.
So now the limits also should be values of t, correct?
Yes,
Because
sir.
here, when we were doing on x, these were values of x. X is a and x is b, right?
Yeah.
So now you have to do values on t, right?
Yeah.
So my new variable t is a plus b minus x. Now think about it. When x is a, what is the value of t?
B.
B. And when x is b, what is the value of t?
And X is A.
Right. So when the lower limit, what was it? X was a, right?
Yes, sir.
So now what is t in the lower limit here?
A. So it becomes T.
B, right?
And oh, right, sir, right, sir.
When x was b, what is t?
A.
So this should be my new integral after converting it into variable t, right?
Yes, sir.
So you are getting an integral minus of b to a f of t dt, right?
Yeah.
Now, one more property that is important is if the limits of the definite integral are interchanged. For example, if I have a to b fx dx, and on this other side I have b to a fx dx, what is the relation between the two? This will be negative.
Yeah.
Why? Because if you calculate the integral, this should be gb minus ga, right?
Yeah. Both of them will cancel.
No, I'm not saying cancelling and all. I'm saying if you calculate this integral, it would have been some g of x plus c, and then you would have put the limit gb minus ga, right?
Yeah.
What will happen if you calculate this integral? It would have been ga minus gb.
Yes, sir. And the negative sign.
That's why I have to put a negative sign.
Yeah.
Do you understand that if you exchange the limits, it should come with a negative sign?
Yes, sir.
So here notice that negative sign and b to a, that can be written as positive sign a to b, right?
Yeah.
So if I write this, now look at this. This is the same thing as the LHS.
Yes, sir.
LHS was just with variable x, now it is with variable t. That value of the area is still the same,
Yeah.
right? So there are three properties that we have seen. Integral a to b fx dx is the same as integral a to b ft dt. The name of the variable doesn't matter. Then a to b fx dx is equal to minus of b to a fx dx, right?
Yeah.
And the third one is a to b fx dx is equal to a to b. Now I can say f of a plus b minus x dx.
Yes, sir.
These properties are very important. You will be using this third property a lot when you do maths and all. It is very useful. So you need to remember it. Other than this, you need to know how to calculate area under the curve. Area under the curve in different situations. For example, let's say we have to calculate the area bounded by the graphs of y is equal to x square and the line y is equal to x plus 3, let's say, with the y-axis. So, for example, I will just draw it first and see what is coming. So, this is the line y is equal to x plus 3, right?
Yeah.
Y is equal to x plus 3. This is the point 0, comma 3,
Yes, sir.
right? And y is equal to x square will be like this, and it will rise up very fast, right?
Sir,
If
it will be symmetrical on the second quadrant as well, no?
it will be symmetrical, it will be like this. But suppose we
Mm.
wanted only the area in the first quadrant. The
Oh,
area bounded by the y in the first quadrant, suppose,
okay.
right? If I have to find that area, let's say, first quadrant area, so that means this area, right?
Yeah.
So how to find such a situation? How to find the area? So first of all, you should figure out where they intersect, right?
Yes, sir.
Because then only we know which limits x goes from where to where, right?
Yeah.
So this intersection point will be when the two graphs are meeting. So x plus 3 should be equal to x squared, right?
Yeah, common solution.
So x squared minus x minus 3 should be 0, and you will get a value of x minus b 1 plus minus root over 1 plus 4, 13 by 2, right? We will not take the
Oh,
negative
yeah.
sign. Our positive sign is the value that we care about right now, right?
Yes, sir.
So this point is basically 1 plus root 13 by 2, and that plus 3 is the y, right?
Yeah.
Correct. So plus 3 would be basically 6 by 2. So 7 plus root 13 by 2. Correct.
Yeah.
That is this point. And this point is 0, comma 3, right? Now,
Yes,
the
sir.
way to calculate the area would be using integrals. How can we do it? We can say that
Upper limit will be the 1 plus root 13 by 2.
no,
And
upper limit is not y, it is always values of x. Do you understand what I'm saying?
yeah, so x's value is 1 plus root 13 by 2, no?
So what you have to do here, because we need only the shaded area, you have to take the full area under the line and subtract the area dotted area, right?
Yeah.
Correct. So we can say it is the area under the line would be x plus 3 dx from 0 to 1 plus root 13 by 2 minus subtract the area under the quadratic, right?
Yeah.
Do you understand what I'm doing?
Yes, sir.
This calculation, the difference of these two integrals will give you the required area. Correct?
Yes, sir.
So many times you will have situations like this where you need to find area under the curve. Usually the way to do it is to draw a rough graph. Once you draw a rough graph, you will get a sense of between where to where you have to find the integrals, right?
Yeah.
Once you know the limits of integral, you have to see under which graph's area do you need to do it, like area under which graph, and then subtract appropriately, right?
Yeah.
Okay. Now in the integration and definite integral exercise, uh, is there any problem that you have faced?
So I didn't try much today.
Okay, so then you have to try. We cannot do the class unless you try enough. Okay.
Yes, sir. I will try enough today and tomorrow.
So we'll do an extra class maybe later to solve your doubts. But now we have to start the physics part also after this. Next week onwards, Monday class onwards will be for physics. Okay. So
Okay.
you have HCV book, right? You have
Sir,
H.
I'm actually not in town and I didn't brought the book with me.
तो फिर कैसे पढ़ोगे बिना बुक के? कितने दिन तक हो बाहर?
Just for today.
Okay. So you will be back by Monday, right?
Yeah.
So what we need to start is chapter 3, kinematics. Okay.
Yes, sir.
So you need to read the kinematics chapter. We'll be discussing that on Monday's class. Okay.
Okay.
So read the kinematics chapter. The way to prepare for the exam, at least in the remaining time, 3.5 months, 3 months is there. So what we have to do is do as much of HCV as possible. As
Okay.
much as possible to a decent level. Decent level means 60 to 70% of HCV exercise you should be able to do.
Okay.
Or more if possible. But we have to cover as much of the syllabus as possible. So the plan is mechanics, electromagnetism, heat and thermodynamics, then optics, waves and sound, and modern physics. This is the order. Okay. So
Okay.
it totally depends on your speed, how much you can do. Because I can teach the syllabus in time. It's just up to you whether you can work on it or not. We will not proceed unless you solve 60 to 70% of HCV. Do you understand what I'm saying?
Yes, sir.
You cannot go to the next chapter unless 70% of the previous exercise is done. Okay. So
Okay.
the amount of work that you put in, the pace will be decided by that. Okay.
Okay.
And it is possible to do it in 3-4 months. At least these 3 sections we can do if you work hard.
So we
These
can skip optics because I did optics for 2 months
Mhm.
before this month. So that chapter is covered. So basically 4 chapters can be complete.
This is not a chapter, dude. There are many chapters in this.
Yeah, topics.
There are many chapters in this. This is roughly 10, 12 chapters here, 10 chapters here, 8 chapters, 9 chapters here, and then 4, 5 chapters here. Okay. So the target should be these 3 things. If you finish by the date of the exam, you will be able to solve a good portion of it. Okay.
Yeah.
But this also will require a lot of like work from your side. You will have to do it like before every class, you have to be ready. Okay. So
Yes, sir.
by being ready before a class, I mean, like I have said, chapter 3 will be discussed on Monday. You should have read the theory of the chapter before the class. Read the
Okay.
theory, and if you have time, you should even start solving some questions. Then I can solve your doubts faster. I can explain whatever you didn't understand, and it will be much easier for you.
Yeah.
So it totally depends on your effort. You have to be prepared. And obviously, if we finish all these 3 big topics by November, then it will be a great advantage for you in your JE prep also later.
Yeah.
So it will be a huge advantage if you know all of these things from before. Okay, so
Yes, sir.
work on it. Make sure that next 3-4 months are all about physics, all about HCV, how much you can do. Okay. Nothing
Yes,
else
sir.
is as important. The only thing I would say on the side you should do is NCERT maths book chapters. NCERT maths chapters which we have discussed, the calculus part, you should work on that.
And sir, I should also continue that Thomas and Finney book, right? I am completed that preliminaries chapter, so I should continue that or leave it.
No, no, if you're doing it, continue it. That's a very good book. But I
Okay.
thought you were not doing it. That's why I didn't say it.
No, sir, I did the first chapter,
Are you understanding what is happening there?
most of it.
So any problems there, you can ask me, but continue that if you're doing it. And you can also practice from the NCERT maths books.
Okay.
But other than this, you should not focus on anything else. Don't do anything else. Only HCV plus all this.
Yeah.
The only thing other than this that you should work on in the next few months is maybe your school test. If there is some tests and all, you have to prepare for them, right?
Yeah.
Your boards are in March and all, right?
Yes, sir.
So board preparation can happen even after the exam. Exam is on November 26th, correct?
Yes, I am not preparing for boards right now by any means.
So board preparation can happen after December.
Yeah.
There is enough time after December to prepare for that. So right now, the next 4 months should be all about this. Okay.
Yes, sir.
Okay. Work on it. Monday we'll start our physics. Make sure that you're prepared for chapter 3. Okay.
Yes, sir.
Fine. That's all for now.
Thank you, sir.
Bye.